let's say you're given a function of x and y, and you're also given that x and y are a function of t. So f is a function of x and y is a function of t. And the question is, what is df dt? And it's suggesting that I do two ways. First, find f of t. Well, what does that mean? I want f as a function of t. F as a function of t is 2 instead of x. X is cosine 3t, right? And instead of y, y is e to the t. So that says you have 2 cosine 3t, and if you exponentiate these two, multiply, you get e to the 2t. And if you know f of t, then df dt is just a derivative that you learned in calculus 1, which is simply it's a product of two functions of t, so you just have to use the product rule. And cosine differentiates to negative sign, but because of the chain rule, there will be an extra 3 multiplied, so it will be negative 6 sine 3t times e to the 2t. And differentiate e to the 2t will give you 2 times e to the 2t, so it's plus 4 cosine 3t e to the 2t. And therefore, the answer would be, if you factor the e to the 2t out, it would be e to the 2t times negative 6 sine 3t plus 4 cosine 3t. Sorry, I don't have enough space here. Okay, now what is the second one? The second one asks you to use the multivariable chain rule. What's the multivariable chain rule? It's trying to measure how f changes with respect to change of t by seeing how the variables affect each other. Changing t will change the value of x, and that's going to change the value of f, right? But t changing would affect f in a different way too. So you have the first way, so here's the formula. df dt is sum of these two different ways that t affects f. So one way f gets affected is through x. So t affects x and x affects f. Plus t affects y and y affects f. Okay, so change of f over change of x, what is that? Well, that means it's a partial derivative with respect to x, and that means you are treating 2ny squared as just a constant multiple of x. So differentiating x just gives you 1, so it's 2 times 1 times y squared times dx dt. What is dx dt? Well, x is cosine 3t, so dx dt using the chain rule will give you negative 3 sine 3t, right? Whereas dy dt would be just e to the t, right? So here dx dt you have to multiply by negative 3 sine 3t, whereas plus the next one, df dy would be, if you differentiate this by y, you're now treating 2x as a constant. Y squared differentiates to 2y, so it's 4xy times the derivative of dy dt, which is just e to the t. So that's the result you get if you simplify. Let's see, if you simplify negative 3 times 2, that's negative 6y squared sine 3t plus 4xy e to the t. So that's the result that you get if you use the multivariable chain rule. And at first glance, that they don't look the same, right? But it said also show that they are equal. So how do we know that these two are equal? Well, all you need to do is just replace y by e to the t, because y is e to the t and x is cosine 3t. So you can further change this by saying y is e to the t plus 4 times x times, well, and x is cosine 3t, y is e to the t, e to the t. E to the t times e to the t is e to the 2t. Same thing here, e to the 2t, right? So you can factor the e to the 2t out. And if you look at what's left is, you get exactly negative 6 sine 3t plus 4 cosine 3t, and you're done. Okay? So that's how you use the multivariable chain rule.